which is 150, which means that lowercase c needs to be the side length opposite of that. So we're focusing on, with law of cosines, finding that angle first and then saying, okay, well then c, the lowercase c, has to be the opposite side length. And then from there, a and b doesn't matter. As long as one of them is a and one of them is b. Okay, c squared, so x squared equals a squared plus b squared, 6 squared, which kind of looks like b, minus 2 times a times b times cosine of c. Plugging this whole thing into my calculator, I get that x squared is equal to 95.8. I take the square root of the exact value above, bringing it back down, and I get that x is equal to 9.79. And remember my hypothesis where I said, hey, well, looking at this and knowing the relationship of an angle on its opposite side, it's definitely going to be larger than 6. But if I got an answer like 100, or if I got an answer like 95, I would stop and say, wait a minute, 95 seems like way too large for a side length in a world of 6 and square root of 17. So hopefully things like that will help you realize, like, oh, I forgot to take the square root. All of these small little things can trip you up for sure, but just taking a step back and always just looking at it and saying, does this make sense? Do these numbers work well together? All right. When you have 3 side lengths and no angle, we use the law of cosines to solve for at least one of the angles. It's kind of a pain in the butt, but we'll talk about the algebraic process. Okay. In each of these triangles, find the angle to the nearest degree. I think we can do it using our calculator. That's why I paused. And we're going to explore together on whether or not we can use our calculator. I'm going to talk about the angle first. I know that my angle is theta. C is theta, which means that lowercase c is its opposite side, 10, which means that A doesn't matter, but one of them, and B doesn't matter, but the other one. Write out your formula. Put in all the pieces that you have and get set up for success. We have 10 squared equals, c squared equals a squared plus b squared minus 2ab cosine of c. Now, order of operations, we would have to subtract out 7 squared. We would have to subtract out 11 squared. We'd be left with negative 2 times 7 times 11 times cosine. And then we would have to divide all of that out. And then we would take the inverse cosine in order to get angle. It's a big algebraic process. And I know with a lot of you that brings a lot of anxiety. So let's talk about how to use our calculator, because you're showing me here, you understand the concept, you know what's going on. And solving algebraically is slowly starting to become like a thing of the past. So let's talk about how to use our calculator. I'm pretty sure, let's double check. With a TI Inspire, you can do your linear solve. So if you're in Calculate, go to Menu, Numerical Solve. So go to Algebra, and the Numerical Solve is the first option. And then I would do 10 squared equals 7 squared plus 11 squared minus 2 times 7 times 11 times cosine of, and I'm going to do x. Remember to put in your comma and then another x to remind or to tell the calculator, hey, I'm solving for x. And I get that theta, or x, is equal to, but really theta is equal to 62.96, which if we're doing 3 sig figs, that's going to be 63.0 degrees. And normally we don't do 3 sig figs for angles, we just do to the nearest degree. If you do not have a TI Inspire, you are going to solve it by graphing. So you're going to go to your graphing calculator. I have to erase all of my things that are on there. We have one side, or we have y equals 10 squared, which is 100. And so it's going to be a line at 100. And then we're going to do another y equals, a second equation. That's going to be 7 squared plus 11 squared minus 2 times 7 times 11 times cosine of x. And we should be getting that the sinusoidal wave, as we talked about in our last unit. I don't know if you can see. Like, I can't see. That's terrible quality. Sorry. I can't see where the line 100 is, so I'm going to zoom out because I know at least I need to go up to 100. And then now, I've got, I can see, I don't know if you can see way up top, there's a blue line. And so now I've got a point of intersection that's like right there. So I'm going to go find that point of intersection. And it rounds it to 3 significant figures. If you have a TI Inspire, if you have a TI 84, it doesn't. If you're doing a TI Inspire, this is probably not how you would solve. But mine rounded it to 3 significant figures, which is 63.0. So that's how you solve it, TI 84 versus TI Inspire. So you don't have to know how to do this algebraically. You can use your calculator for everything. And isn't this much more accurate than trying to solve it algebraically? Yes. If you have any questions on how to solve using your calculator, please reach out to me. There's tons of videos out there on YouTube that explain it. Also, Cognity has a bunch of like document explanations of them. I don't think they're as relatable or as attainable in terms of information, but it's an option, and I'm also always an option. Okay, let's try it again. I'm not going to re-explain how to use your calculator, so this is an opportunity for you to try using your calculator and double checking, hey, did I get the same thing? Focusing on my angle first, I have that uppercase c is equal to theta, which means that the opposite side length, which is my lowercase c, is 27. A and B don't matter which one is which. Please don't change it just because mine is different than yours, because you don't need to. It'll be the exact same thing. And then I'm going to write out, you can write out your formula first and then plug in, or if you feel like you've got it, go ahead and just write out the whole piece here. C squared equals A squared plus B squared minus 2 times A times B times cosine of C. I'm going to go to menu, algebra, numerical solve. Okay, this would make sense. It's obviously going to be a fairly large angle. It's going to be larger than 90 degrees, as the diagram is implying here. And I get something that seems correct to me, seems about right. And that is 92.7 degrees. Now, we're going to talk about how to know when to use each one. Our goal when we're solving for anything in mathematics is to always make it a relationship, make an equation that only has one variable. So when you're setting up these relationships, if you ever find that you have more than one variable in that relationship, you're using the wrong relationship. Do the other one. For instance, I might see here that I'm trying to solve for x. I'm like, hey, well, x has an opposite angle of 27. I think I'm going to be using law of sines here because I can do this like fun little circle thing, and I can see that it's matched up. Now, my only other angle that I have is theta, right? Now, if I were to set up that relationship, it would be sine of 27 over x, so one variable, equals sine of theta, another variable, over 30. So I've got x and theta in the same relationship. If I'm using my sine rule or my law of sines, that's two variables, which then we can't solve for anything because you can't. Because if you have two variables, you need two equations, right? So we are not going to do law of sines here. Instead, we're going to try to do law of cosines. So now I'm thinking about it in a different perspective. I'm looking at the angle that I have first, 27. And then that means that this guy, so that means just writing it down so I can zoom in and have good handwriting and not forget. Okay, so that means that our opposite side length is going to be, so our angle. Our angle is going to be 27. Our opposite side length is x. Our other two side lengths are 18 and 30.